A very good morning to all my dear students. In our previous class we already know what is the real numbers. Real numbers means it is nothing but combination of rationals and irrationals. What is a rational number? Rational numbers are in the p by q form where q is not equals to 0 and p comma q are some integers. These type of numbers are called rational numbers. Irrational means it is not a rational. Irrational means it is not a rational. So these type of numbers are called irrational numbers. It is not in the form of p by q, and decimal expansion is completely different from rationals. So let's take one example. In our earlier classes we already know how to find these rational numbers on the number line. So let's revise the concept. This is our first question. Represent three by four on number line. So this is our first question. 3 by 4 means it is a proper fraction. So this 3 by 4 value is always in between 0 and 1. So this is our number line. 0, 1, 2, 3, 4 and so on. Minus 1, minus 2, minus 3 and minus 4. So 3 by 4 is a proper fraction. Denominator is the higher one, right? So denominator is highest. So this value is always in between 0 and 1. So 3 by 4. Here denominator is 4. So we just write each and every positive integer denominator as 4. So here 1 by 4 and 2 by 4 and 3 by 4 and 4 by 4. So this is our required rational number, right? So here let's modify the number line. 0, minus 1, minus 2 and minus 3. So here 1 by 4. 1 by 4 means 0.25, right? 1 by 4. 2 by 4. 2 by 4 means 0.5, right? So here 3 by 4. Here 4 by 4 means value is 1, right? So here proper fraction values are always in between 0 and 1. This is a proper fraction, right? Let's take the each and every integer denominator as 4. So here 1 by 4, 2 by 4, 3 by 4, 4 by 4. 4 by 4 means 1. Here the proper fraction values are always in between 0 and 1. This is our required p by q form. So this is our required fraction 3 by 4. Next one. This is example 1. Represent 5 by 3 and minus 5 by 3 on the number line. Represent 5 by 3 and minus 5 by 3 on the number line. So this is positive fraction and this is negative one, right? This is a positive rational, this is negative rational. So these two fractions are improper fractions. Why? Because here numerator is greater compared to denominator. Numerator is greater, right? So here let's change it into mixed fraction. So here 5 by 3 means 3 ones are 3, remaining carry 2. So 1, 2 by 3 is our mixed fraction. Next one, minus 5 by 3 means minus 5 by 3 is equals to minus 1, 2 by 3. So let's identify these two mixed fractions on the number line. So here 0, 1, 2, 3, 4. Here -1, -2, -3, -4. So this value 1, 2 by 3 means these values are this fraction is always in between 1 and 2. This value is always in between 1 and 2. So here -5 by 3 means this value is always in between -1 and -2, right? -1 and -2. Here 5 by 3, here denominator is 3, right? Denominator is 3. So 1 by 3, 2 by 3, 3 by 3, 4 by 3, and 5 by 3, and 6 by 3. So that is equals to 0, 3, 3 one time, 3, 3 two times, right? So this is our required fraction, right? This is 5 by 3 is our required fraction. So 1 by 3, 2 by 3, 3 by 3 means it is value is 1. Here 4 by 3, here 5 by 3, here 6 by 3 means value is 2. So this is a improper fraction. Let's change it into mixed fraction. So this value 5 by 3 value is always in between 1 and 2. 1 and 2. So denominator, here denominator is 3. Let's take each and every integer on the number line denominator as 3. So 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, and 6 by 3. Here 3 ones are 3. So here 1. Here 6 by 3, result is 2. So the value 5 by 3 always in between 1 and 2. Here 1 and 2. This is our required fraction. Right? Similarly, we have to represent -5 by 3 on the number line, right? So here negative side integers 0, -1 and -2, -3, -4 and -5. So denominator 3. Here denominator is 3. Write each and every integer denominator as 3. So -1 by 3, -2 by 3, -3 by 3, -4 by 3, -5 by 3, and -6 by 3. So the value -5 by 3 is always in between -1 and -2. How? So here 3 ones are 3. Remaining carry 2. So here -5 by 3 means -1, 2 by 3. The value -5 by 3 is always in between -1 and -2. The value is -5 by 3 is in between -1 and -2. Here is also 3 2s are 6. 3 1s are 3. So this is our required rational number -5 by 3. So next. So finally we have to represent 5 by 3 and -5 by 3, right? So here 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So here -1, -2, -3, -4, -5. So denominator is 3 means 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3. So this is our required rational number. Here is also -1 by 3, -2 by 3, -3 by 3, -4 by 3, -5 by 3. This is our required another rational number, that is -5 by 3. This is the way we can represent any rational number on the number line. This is the final result. Okay, my dear? Right. Next question. Third example. Find two rationals between 3 and 4. So here 3 and 4 are integers, right? Find two rationals between 3 and 4 by using mean method. By using mean method. You already know in your earlier classes how to find in between rationals by using mean method. So what is the mean method formula? Here mean method formula is a plus b by 2, right? Here a is equals to 3, b is equals to 4. So in between rationals of 3 and 4 is 3 plus 4 by 2. So that is equals to here 3 and 4. A is equals to 3, b is equals to 4. So in between rationals of 3 and 4 is a plus b by 2. This is the mean method formula. So here 3 plus 4 by 2. So that is equals to 7 by 2. This is the rational number in between 3 and 4. So 0, 1, 2, 3 and 4. So the rational is in between 3 and 4 is 7 by 2. Here 7 by 2. So the rational is in between 3 and 4 is 7 by 2. The rational is in between 3 and 7 by 2 is here a is equals to 3 and b is equals to 7 by 2. So the rational is in between 3 and 7 by 2 is 3 plus 7 by 2 again by 2. Our formula is here a is equals to 3 and b is equals to 7 by 2. Here b is equals to 7 by 2. So that is equals to our formula a plus b by 2, right? A plus b by 2. Here a is equals to 3, b is equals to 7 by 2 by 2. Here the LCM is 3 2s are 6. 6 plus 7, that is equals to 13 by 2 again by 2. So that is equals to 13 by 4. So here this 13 by 4 value is in between 3 and 7 by 2. So 3 comma 13 by 4 comma 7 by 2 comma 4. So here 13 by 4 and 7 by 2 are the two rationals in between 3 and 4. So 0, 1, 2, 3, here 13 by 4, 3 and 7 by 2. 13 by 4 is a rational number, is in between 3 and 7 by 2. So 13 by 4 and here 7 by 2 and here finally 4. So these are the two rational numbers is in between 3 and 4. So finally rational numbers are 3 comma 13 by 4 comma 7 by 2 comma 4. The two rational numbers is in between 3 and 4 is 13 by 4 and 7 by 2. These are the two rationals is in between 3 and 4. This is the way we can solve this type of problems. This is alternate method of same question. So find the two rationals in between 3 and 4. So here find two rationals between 3 and 4. So here two rationals in between 3 and 4. So our formula becomes two rationals means 2 plus 1. So that is equals to 3. Here 3 and 4. So multiply numerator and denominator with 3. Here 2 rational numbers between 3 and 4 means our formula becomes 2 plus 1. Here 3 rationals between 3 and 4 means our formula becomes 3 plus 1, that is equals to 4. Multiply numerator and denominator with 3 or 4 or 5. So here find 3 rational numbers between 3 and 4 means our formula becomes 3 plus 1. Find 4 rationals between 3 and 4 means our formula becomes 4 plus 1, that is equals to 5. So here 2 rationals between 3 and 4 means 2 plus 1, that is equals to 3. Multiply numerator and denominator. Here denominator is 1, right? Here is also denominator is 1. Multiply numerator and denominator with 3. Here 3 by 3. Here is also into 3 divided by 3. So that is equals to 3 3 is a 9 by 3. Here 4 3 is a 12 by 3. So the two rationals is in between 9 and 12 is 10 by 3 and 11 by 3. These are the two rationals between 3 and 4. Here 9 by 3 means 3. Here 12 by 3 means 4. So here rationals are 10 by 3 and 11 by 3. This is very easiest way to find any rational numbers in between two given integers. This is alternative method of first problem. Okay, right? This is the alternate method of third example. So let's take another example. Find 5 rationals between 5 and 6. 5 and 6. Find 5 rationals between 5 and 6. So here 5 rationals means our formula becomes 5 plus 1, that is equals to 6. Multiply numerator and denominator with 6. Here 5 and 6. Multiply numerator and denominator with 6. Here denominator is 1. Here is also 1. So into 6 divided by 6. Into 6 divided by 6. So that is equals to 5 6 are 30 by 6. Here 6 6 are 36 by 6. Here 31 by 6. 32 by 6. 33 by 6. 34 by 6. 35 by 6. So here these are the 5 rationals in between 5 and 6. This is the way we can find any rational numbers in between two integers. This is alternative method. This is our first mean method. This is our mean method. This is alternative method. Okay. Next our question, example 4. Express 7 by 16, 10 by 7 in decimal form. First our question is 7 by 16. Express given fraction in decimal form. So here 7 by 16 by using long division method. So we already know how to find decimal form of given fraction. So here divisor and dividend, quotient and remainder. So here 0.0. So 16 fours are 64. So remaining 6 0. So here 70 minus 64, result is 6. So 0.0. Here 16 3s are 48. So that is equals to 12.0. Let's take 0. So 16 sevens are 112. So deduction result is 8. Remaining, let's take 0. So 16 5s are 80. Finally result is 0. Remainder is 0. So here So that is equals to here quotient value is 0.4375. Here divisor is 16, dividend is 7. So 7 by 16. Result is 0.4375. 0.4375. It is a terminating. Terminating means here remainder is 0. The remainder is 0. So that is a terminating decimal expansion. 7 by 16 has a terminating decimal expansion. Next our question is 10 by 7. So 10 by 7. So that is equals to 7, 10. So 7 ones are 7. So remainder is 3. So 0.0. Next 7 fours are 28. Result is 2, 0. So 7 twos are 14. So result is 6, 0. Here point. Let's take 0. So 7 eights are 56. Result is 4, 0. So 7 fives are 35. So that is equals to 5, 0. 7 sevens are 49. 50 minus 49. Result is 1, 0. So here 50 minus 49 is equals to 1. So 0.0. Here is also 7. 7 ones are 7. So that is equals to 3, 0. So 7 fours are 28. So result is 2.0. Here 10 is repeated. So here 10 is repeated, 30 is repeated, 20 is repeated. So similarly in this decimal expansion 1.428571, these are all repeating decimals. Similarly here these are all repeating decimals. 1.428571, 1.428571. Here 428571. These are all repeating decimals. So 10 by 7 is equals to 1.428571. So it has a repeating decimal expansion. This is the final result. Next question. Express 3.28 in P by Q form. This is example 5. Express 3.28 in P by Q form. So here after the decimal point, how many decimals are there? 2 decimals. For 2 decimals, multiply numerator and denominator with 100. For 1 decimal, multiply numerator and denominator with 10. For 3 decimals, we can multiply numerator and denominator with 1000. So here after the decimal point, how many decimals? 2 decimals. For 2 decimals, multiply numerator and denominator with 100. So 3.28 into 100 divided by 100. So that is equals to 328 by 100. So finally result is 82 by 25. So here 25. So here 25 fours are 100, 4 25s are 100, 4 8s are 32, 4 2s are 8. So 328 by 100 is equals to 82 by 25. This is the P by Q form of given decimal 3.28. This is the P by Q form of given decimal 3.28. So 3 here 3.28. P by Q form, simplified P by Q form of 3.28 is 82 by 25. This is the final result. Next question. Express 1.62 bar in P by Q form. P by Q form. So look here, students, this is a terminating decimal expansion. This is non-terminating and repeating, or non-terminating recurring. This is non-terminating, this is terminating. So in non-terminating, this is a repeated decimal expansion or recurring decimal expansion. In our previous examples, we already know this is the example of 7 by 16. This is example of 10 by 7. So this is non-terminating, this is terminating. This is in non-terminating, this is a repeating decimal expansion. So here 1.62 bar means 1.62, 62, 62 and so on. Two decimals are repeating decimals. So that is equals to, here two decimals are repeating decimals. Let's take this value is x. X is equals to 1.626262 and so on. For two decimals multiply with 100. So that is equals to 100. X is equals to both sides LHS and RHS multiply with 100. 100x is equals to 162. Here two decimals 1.62. Here two decimals are goes to left side. So 162.6262 and so on. So this is equation 1. This is equation 2. This is equation 2. So here equation 2 minus 1. So that is equals to 100x and equation 1 is x. So that is equals to 162 point, here 100x is 162.626262, right? So 62, 62 and so on. Here x value is 1.62, 62 and so on. So here 100x minus x, 100x minus x, here operation is minus. 99x is equals to 162. 162 minus 1 is 161 point. These are all zeros. Why? Because 62 minus 62. These are all zeros. So all decimals are zeros. Decimal values are all zeros. So on. So that is equals to x is 161 by 99. So finally our result is x is equals to, so 99 transpose 161 by 99. This is our P by Q form of, this is our P by Q form of 1.62 bar. So x is equals to 161 by 99. So 1.62 bar P by Q form is 161 by 99. This is the P by Q form of 1.62 bar. This is a non-terminating and repeating decimal expansion. So P by Q form is 161 by 99. Okay, my dear students, if you have any doubts in this session, please contact my number. Thank you.